And once again, we are on to our favorite part of every lesson where we try out actual SAT and ACT problems. This one is from the 4th SAT exam, section 4, which means we are allowed to use a calculator if we need one. Let's go ahead and read it. In the circle above, segment AB is a diameter. If the length of arc ADB is 8 pi, what is the length of the radius of the circle? Go ahead and try this question and then come back to see if you got the answer right. To answer this question, we just draw on the information given. We're told that AB is a diameter, which means the center is somewhere around here. And the question is asking us to find the radius of that circle. Given that arc ADB is 8 pi. Notice that that arc is pretty much half of that circle, so the other half of this circle would also be 8 pi. That means we can find the full circumference by simply adding 8 pi to 8 pi. 8 pi plus 8 pi ends up giving us the full circumference of that circle, which is 16 pi. Recall that circumference of a circle is basically found by saying pi times the diameter. So if the circumference is 16 pi, can we then not say that the diameter is 16? Yeah, the diameter of this circle is 16. The distance from A to B is 16 because that's diameter. We are looking for the radius, which is halfway that distance, which means C is the answer to this. Half of 16 is 8. Our next question is from the second practice SAT exam. This is section 4, which means we can use a calculator if we need one. In the figure above, point O is the center of the circle. Line segments LM and MN are tangent to the circle at points L and N respectively, and the segments intersect at point M as shown. If the circumference of the circle is 96, what is the length of minor arc LN? Please try this question and then continue on to see if you got the answer right. Let's try to solve this problem. We are told that LM is congruent to MN. LM is congruent to MN. Moreover, we know that LM is tangent to the circle. Notice that LM is intersecting a radius, and remember that's a special idea that we talked about. Anytime a tangent comes into contact with a radius or a diameter, they intersect at a 90-degree angle. So we know that's 90 degrees. That means this is also 90 degrees. Also, notice that there's a quadrilateral, the four-sided figure right here, OLMN. Anytime you have a quadrilateral, you can find missing angles using various rules and facts that we know about them. One of the facts is that opposite angles in a quadrilateral always add up to 180. That is to say that opposite sides in quadrilaterals are supplementary. As you can see, angle L plus angle N would be 180. 90 plus 90 is 180. So that can also be applied across. So angle O plus angle M should equal 180 degrees. If we know angle O, we can add it to the 60 to get 180. So to find O, we'll just subtract 60 from each side, and we find that the measure of angle O is 120 degrees. So this angle here is 120 degrees. Why is that important to us? Well, because this question was asking us to find the length of minor arc LN. Moreover, we've been given that the entire circumference of this circle is 96. So if you're going to measure the distance around this, we would find that that's 96 units. So notice that arc LN is a small part. It's just an arc, a small part of the full circle right here. And remember how we came up with an arc length formula? We found out that to find the length of an arc, you find the angle that you're talking about over 360 degrees times pi times diameter. But guess what? We have been given pi times diameter. Remember, this is the circumference, and that's given to us as 96. The angle that gives us arc LN is 120 degrees as we found it. So we know 120 over 360 times the circumference, which is pi d, given to us is 96, will give us the length of arc ln. So 120 goes into 120 once, 120 goes into 363 times. So what's 1/3 of 96? We can find out the length of arc ln by dividing 96 by 3, which ends up being 32. So the answer to this question is 32. It is a free response question, so make sure you enter 32 and then shade the appropriate bubbles. Our next question is from Practice ACT test number 67C. In the circle shown below, chords TR and QS intersect at P, which is the center of the circle, and the measure of angle PST is 30 degrees. What is the degree measure of minor arc RS? Please go ahead and try this question on your own and then come back and see if you got the answer right. All right, so to solve this question, we need to find the degree measure of arc RS. Remember, we've talked about arcs and angles that form them. So to find the degree measure of arc RS, we would need to know this angle here, because that angle is the one that intercepts arc RS. Notice that this is a central angle. This is a central angle. It means it's going to be the same measure as the arc that it's intercepting. So for instance, if this were 10 degrees, this would also have to be 10 degrees based on what we learned. So our biggest task is to figure out the measure of this degree, that angle. We know that TR is congruent to QS. Those are both diameters. Now, what's more important to us in this point is the following. TP is congruent to PS. Why is that? Well, they are both radii from the center to a point on the circle. So we know this is congruent to that one. That makes triangle TPS an isosceles triangle. That means if this bottom angle here is 30 degrees, this also has to be 30 degrees, which means we can then find this vertex angle here. So I'm going to expand that triangle so we can just read it a little bit easier. P, T, and S. We know this is 30. This is 30. We need to find this angle here. And finding it is easy because angles in a triangle add up to 180. So 30 degrees plus 30 degrees plus angle P should be 180. 60 plus angle P is 180. Subtract 60 from each side, and you find that the measure of angle P is 120 degrees. So if this angle here is 120 degrees, we can then turn our attention to these two angles here. How do they relate? The 120 we just found and this angle here form a linear pair. A linear pair is formed when two angles share a side. So if we have this as 120 degrees, we can definitely find this one by subtracting it from 180. 180 minus 120 is 60, which means this angle here that we needed is 60 degrees. Remember, if you're looking for the degree measure of an arc and the angle that intercepts it is a central angle, they have the same degree measure. So the degree measure of arc RS is also 60 degrees, which makes H the answer to that problem.